In question 1, we analyze two discrete time constant signal S1 and S2n. S1n use a frequency of 0.3 pi and is defined from n equals 0 to 16. So it has 16 samples. Although the frequency is rational, the fundamental period is 20 divided by 3, which is not an integer. That means SYN is not perfectly periodic. S2n is a modified version with frequency 0.22 pi and is also result in a non-integer period, so it not periodic either. The main difference between S1n and S2n is the frequency, which change how the signal looks. In question In questions 2, we look at continuous time depend complex sinusoids. The type of signal oscillates like a wave, but its amplitude decreases over time due to damping. It is important in engineering because it models real systems like vibrator, electronic circuit, or transient response.
Assalamualaikum. My name is Muhammad Shafiq bin Muhammad Hussein, number metric S73011. Today I'm gonna to present about the question 3. First of all the methods first step, the way we can combine signal affect the intermediate result like VN, but not the final outcome. The final outcome is consistent, which is no matter how we order the system, the final output YN is the same because of the nature of convolution. In summary, while the order of operation can change the immediately result, it does not change the final output in linear system. The property is crucial for understanding how different filters can apply in the signal processing without affecting the end result. After running the Matlab code, we obtain a numerical result for YT. We can also compute the analytical result by evaluating the convolution integral over a specific interval. Any difference between the analytic and numerical result may come from how Matlab discretize the signal. This can introduce small errors, the choice of time resolution and method used for convolution, like same option, can also affect the result. In the exercise, we can convolve the triangular signal HT with the exponential sine signal HT using both analytical and numerical method. The Matlab plot help us visualize the original signal and their convolution result.
In this exercise, we studied how an ideal phase low-pass filter affect different signal. First, we calculated and plotted the filter impulse response, which show how it reacts to a sudden input. Then, we used sinc function as the input signal and found the output by convolving it with the impulse response. This shows us how the filter smooths the signals and remove high frequency noise. Next, we look at periodic square wave and use a Fourier series to break it down into a sum of sine wave. We plotted both the original and filtered square wave, and we saw how the filters soften and the sharp edges. Overall, this exercise helped us understand how low-pass filters work and why they are useful for cleaning up and improving signals.
Hello everyone, my name is Muhammad ASHRAF bin ABDUL Jalahan. My metric number is S70420. So I will talking about the question 6, which means the last part of this report. Do you know if we use the MATLAB, we created a pole zero map to visualize this point. The pole at the S equals to S2 clearly indicated instability. as a lie outside of the safe zone for stable system. Next, we look the impulse response of this system by using Matlab residual function for partial fraction inspection. We found that the response include the exponentially growing term. This confirmed our early finding of instability. The impulse response for the system consisted of decaying exponential, which it was we expect from the stable system. In summary, we learned that the location of pole equation in determining system stability. Our first system was unstable due to the pole in the right half plane, while the second system, based on a physical differential equation, was stable with the all pole in the left half plane. MATLAB provides us with powerful tools to analyze and visualize this system effectively.